Okay, so let's get started with the lab. The first thing we need to do is you'll see in the instructions is we're going to go over and find out what the true age is of our quote population. Again, we're treating this as, of course, sample data because it's the General Social Survey, which is a sample study, but we're going to treat this data as population data just for the purposes of illustrating how a confidence interval works. Of course, in the real world, we would never have a true population mean, but in this case, we do. So we're going to go up to Analyze, the Analyze tab here, Descriptives, click over here to Descriptives, and it's going to ask us to drag a variable. We want age of respondent. Your file may appear somewhat differently. Sometimes these are alphabetized one way, sometimes they're alphabetized a different way. I've never been able to understand how SPSS decides which way to lay out these variables, but you will find age of respondent there. There's no question about that. All right, so we've dragged age of respondent over into the variable section, and now we're going to simply click OK, and SPSS will run some descriptive statistics and present them in this output window that we see over here. And indeed, the correct age, the true age of everyone in this population is 50.12 years. Okay, let's go on to the next step. The next thing we want to do is we want to select, keep this open or close it out, it doesn't really make any difference. The next thing we want to do is pretend that we are sampling from our population of n equals 1490. So to do that, we go over to the Data tab, come down here to where it says Select Cases, select a random number of cases. We're going to click Sample, and we want to, first time we do this, we want to select about 150 cases from the first 1490, or you can really put any number greater than 1490. I think this will work. So we're going to click Continue. Now we're going to click not OK, we're going to click Paste. All right. And now what SPS has done is opened what's called a syntax window. Those few mouse clicks that we just went through, that select cases procedure, has behind the scenes generated all this code. All right. Now, I want to do one more thing. I'm going to skip 2 lines just to make this a little bit easier to read. I'm going to go over to Analyze, Descriptive Statistics again. This time, though, I'm going to use the Explore procedure because Explore will give me a confidence interval. Descriptives won't give me that confidence interval. So I'm going to click Explore. Again, we're going to find age, move that into the dependent list. Okay. And what else do we want to do here? We want to check statistics because we don't need plots. They just take up a lot of space on that output window. And again, we're going to click Paste. So what we've done again is we have added in all of those commands. Let me get rid of a couple of these lines. I have too many, I think. Right. So all of those, that whole procedure that we just undertook of going Analyze, Descriptives, Explore, selected the variable, indicated we don't want to plot, etc. All of that is enclosed in these 5 or 6 lines of code. All right. Now what I want to do is I want to select all of these, and I want to click this Run button over here, Run Selection. For some reason, this is grayed out. I don't really quite know why that is, but at any rate, we're going to click Run Selection. And what SPS has done is it's drawn a sample, in this case 148 cases, even though we asked for 150. For some reason it generates a few more cases or a few less cases. Again, I don't know why that is. But we want to make sure that we selected about 150 cases. So that's what we have over here. The mean of this sample of cases, the mean of this random sample of cases is 48.86. The lower boundary of the confidence interval is 46.26. The upper boundary of the confidence interval is 51.46. So what do we want to do? We want to go ahead and record, as indicated in the instructions, our mean, the lower boundary of the confidence interval, and the upper boundary of the confidence interval. The way I've set up the spreadsheet that you'll be entering this information into, I would suggest on your sheet of paper, you first enter the lower boundary, then the upper boundary, then the mean, because it will make the data entry task that you have to perform a little bit later a lot easier. All right, so that's our first run. Now, here's the beauty of programming. We can go back and we can run this again. I'm going to press Control A to select all of the cases. I could just select those with my mouse if I wanted to. We're going to run this again. And you'll see this is the one we just ran, and this is the one we ran before, and this is the one we just ran. So this is a different sample. This time SPS pulled, in fact, 150 cases as we requested. This time our mean is 50.59, with the lower boundary of the confidence interval being 47.7, the upper boundary being 53.48. All right, so as per the instructions, you're going to run this procedure a total of 20 times. We ran it twice, so you're going to run it 18 more times. Each run, you're going to record, again, the lower boundary of the confidence interval, the upper boundary of the interval, and the mean. All right. Let me just click into the syntax window again. Now we're going to make a change. Now I don't remember offhand which order I told you to make these changes in, but let me show you how to do it. This 150 here indicates that's where we told SPSS we want a sample of 150 cases. Now we're going to ask for a sample of 20 cases. And just so we know what's going on, we're going to change the label to 20 cases. All right. And we're going to now do the same thing we did before. I'm going to click Control A, run this, and here's my next set. Verify, we have about 20 cases, exactly 20 in this case. Our mean is 49.65. Our confidence interval, the lower boundary, 42.22, upper boundary, 57.08. You will notice, very important, you'll notice that when our sample has only 20 cases, our confidence interval becomes much higher, much wider than any other case. And you'll be illustrating that in Excel after you've run this now a total of 20 times. I'm not going to do that here, but again, you're going to go back, select everything, and run it 20 times. Now, let's change this again. Let's change this back to 150 cases. Change that one there, as per the instructions, back to 120 cases. This time, however, instead of asking SPSS to produce a 95% confidence interval, we're going to ask for a 60% confidence interval. So all we need to do is just change that to 60. See how much easier the code is than having to go through this 20 times using the graphical user interface. Again, I'm going to select it all, click Run, and there's my result for a 60% confidence interval with n equals 150 cases. All right. Again, we're going to double check that that n is correct, and we see the mean 49.46 and a much more narrow confidence interval than we had in the other case, between 48.32 and 50.59. And then finally, we're going to run this again 19 more times for a total of 20. And then finally, we're going to run another set of 20 60% confidence intervals. This time, however, we're going to go back to 20 cases. So we'll put that 20 over there and a 20 over there. And I'm going to leave this at the 60%. Select the whole thing and click my Run button. And there you have it. Okay, so that's part one of this lab. You've now selected you now have 4 sheets of paper, each one labeled as I described in the instructions. One for the 95th confidence interval, n equals 150. One for the 95th confidence interval, n equals 20. One for the 60th percent confidence interval, n equals 150. And finally, one for the 60th percent confidence interval, n equals 20. So you've got 4 sheets of paper. Each one has 20 rows on it for a total of 80 rows of data. All right, let's move on now to what we're going to do with that in Excel. Okay, so now I have closed out of SPSS. I have downloaded and opened up the confidence interval template file, saved up on Blackboard, and I'm ready to start working in Excel. So you'll notice here that I have a spreadsheet that has a number of tabs. Your spreadsheet will only have these 4 tabs down here at the bottom: the 95th with n equals 150, the 60th percent confidence interval with n equals 150, the 95th percent confidence interval with n equals 20, and the 60th percent confidence interval also n equals 20. These others you can forget, they're just for my use right now and demoing this for you. All right, so I have collected on a separate sheet of paper, as you have, a listing of the confidence intervals and means for my runs of each one of these different scenarios. And let's start with the first one. I'm going to put this in this demo area, but we're going to enter the low of the confidence interval over here. 47.39 was my first one. And the high value of that confidence interval is 50.73. And the mean value for that confidence interval, for that sample, was 49.89. Okay, I'm going to press enter, and let's enter another one. 46.54 was the low end of that confidence interval. 52.65 was the high end, with a mean of 47.90. Okay, let's take a look now at what's happening in the chart area. Each one of these vertical lines represents a confidence interval. Each one of the little horizontal lines that you see represents the mean for that sample. So you can see that this line graphically depicted here, the high end of that is at, looks like about 52, and that is in fact pretty close to what it is. The low end looks like it's about 46 or so, and indeed it's 46.54. And the mean is a bit more, we'll call that about 47.5 maybe, 47.9, I see. All right, so that's what this shows. What I'm going to do now, I'm going to do this offline, but what you'll do is you'll fill in the low, high of the confidence interval and the mean for each one of the 20 samples that you drew, where you're asking SPSS to create a 95th percent confidence interval in the run where n equaled 150. I'm going to pause the video and fill these in for you so you can see what this chart is going to look like. Okay, so now I have all 20 confidence intervals, and let's see what we can do to make this chart look a little bit nicer. The first thing we'll do is make the chart a little bit larger by selecting it. Oops, by selecting it and drawing out these handles on the corners. All right, so we have a black and white chart right now. Let's see if we can get these a little bit more color to this. So I'm going to click on any one of these high-low lines. All right, I'm going to then right-click, Format High-Low Lines. And that opens up this area on the right-hand side. And let's change the color of our lines to a nice blue, perhaps. And we'll make them a little bit wider like that. All right, that looks pretty good. Now let's change these mean markers. So let me click on a mean marker there. Any one will do. Oops, that time it's a little tricky. This time I accidentally clicked on the high-low line. Let's try to click on the mean line. Let me get out of that. It's going to be a little tricky. Oops, again. There we go. That time we got all of those little mean lines. We're going to go over here to our paint bucket, fill in line, click on marker, and let's make our markers, let's make them this deep red color. I have to also change that down over here in the border area, and you see we now have red markers. They're a bit small, so maybe I'll make them just a little bit larger. There we go. All right, that looks pretty good. There's one, well, actually, there are two more things to do. Let's add a line to indicate what the true mean of the population was. You'll recall that the true mean was 50.12. So let's go over here to Insert, Shapes, and we'll select Lines. And all we can really do this is by eyeball. That's about 52. Going to hold down the Shift key, click, and drag across. And to differentiate that mean line, I'm going to make it a different color. Let's make that mean line, in this case, let's make it a nice, oh, let's make it orange. How about that? There we go. Oops, orange. There we go. And I'll make it, well, actually, we'll keep it at the width of 0.5 there. Okay. Just one last thing to do, which is to add a meaningful title. I'm going to click on chart title here and triple click. I think you have to do. It's a bit tricky. And we'll just give that a label describing what this chart shows. This shows a 95th percentile confidence interval for the case where n equals 150. And there you go. So what this graph shows you is really the number of confidence intervals that capture the mean, and it looks like the majority of them do, and also shows you that at random, these are all random samples, and as such they had different means and different standard deviations, and because they had different standard deviations, they also had different standard errors. So some of the lines, some of these confidence intervals are very narrow, such as this one over here, which doesn't actually include the true mean for the population, or very wide, like this one over here, that happens to, in fact, capture the true mean of the population. Now I'll just tell you a little secret here. These figures are really just a set of random numbers. I wasn't going to take the time, unfortunately, to do what I'm asking you to do, which is to actually record real data here. With real data, you wouldn't see anywhere near this number of confidence intervals that do not contain the true population mean. You may see some, you may see one or two, but you can get into a discussion of that when you look at the questions that I'm asking you to answer in the lab. Okay, I hope that you found this helpful.